Welcome to the DIY Honda Garage channel. The DTC B1036 indicates a driver's microcomputer intercommunication unit (MICU) ignition switch line input error for Honda Accord models from 2008 to 2012. This error is critical as it relates to the functioning of various electrical systems and modules within the vehicle that depend on the Ignition 1 (IG1) line for operation. The component affected primarily is the driver's under-dash fuse relay box. Located under the driver's side dashboard, if there is a fault in the IG1 line, it may prevent critical electronic components from receiving the necessary power supply, leading to system malfunctions. Correctly diagnosing this issue is essential for restoring proper functionality to the vehicle's ignition circuit and ensuring reliability. The diagnostic procedure must be followed meticulously to identify and resolve the underlying issue causing the DTC B1036 error. DTC B1036 refers to an input error associated with the driver's microcomputer intercommunication unit, MICU, specifically regarding the Ignition 1 IG1 line. The MICU is integral to managing power distribution to several electrical components, including the lights, power windows, and various sensors. Its primary location is under the driver's dashboard, housed within the fuse/relay box. The IG1 line is an essential part of the ignition system, responsible for supplying power when the ignition is turned on. If the MICU cannot receive the correct signals from the IG1 line, it could cause significant operational issues, making it vital to address this error promptly. This malfunction may impact the overall functionality of the vehicle's electrical system, leading to further complications if left unresolved. Several possible causes could lead to the DTC B1036 error code being triggered. First and foremost, a blown fuse, specifically the number 5 fuse rated at 7.5 amps, located in the driver's under-dash fuse relay box, may be the culprit. If this fuse is faulty, it won't allow the necessary voltage to flow through the IG1 line, leading to a malfunction. Additionally, poor or loose connections at the connectors, especially at the driver's fuse relay box connector C, can interrupt communication within the electrical system. Lastly, there might be a fault within the MICU components themselves, which could necessitate replacement. Identifying these potential causes is crucial for pinpointing the problem and ensuring a complete and effective repair. The symptoms associated with the DTC B1036 error can manifest in various ways, predominantly affecting electrical components' behavior. First, users may notice that certain electrical functions, such as power windows, lights, or dashboard indicators, may not operate as expected. These failures often point to issues with the ignition system, as the MICU relies on the IG1 line for power. Additionally, drivers may observe warning lights illuminated on the dashboard, indicating faults within the system. Furthermore, intermittent electrical disruptions may occur, where components function sporadically, reflecting the instability of the electrical architecture. Collectively, these symptoms underline the urgency of diagnosing and rectifying the DTC B1036 error to restore proper vehicle operation. The first step in troubleshooting the DTC B1036 is to clear any existing diagnostic trouble codes, DTCs, using the Honda Diagnostic System, HDS. This procedure involves connecting the HDS tool to the vehicle's diagnostic port and selecting the option to erase DTCs. After clearing, ensure that all vehicle systems are reset and ready for testing. It's crucial to perform this step to eliminate any potential intermittent codes that may not signify a current issue. Once the DTCs are cleared, it is imperative to ensure that the HDS is set to the correct test mode for further diagnostics. This initial step helps establish a clean baseline from which to assess the performance of the MICU and the IG1 line. Following the clearing of DTCs, the next step involves turning the ignition switch to the lock position. This step resets the electrical system, ensuring that it initializes correctly. Immediately afterward, switch the ignition to the on position. 2. This action is critical as it prepares the MICU and other related systems for a diagnostic check. After switching to the on position, it's essential to wait at least 6 seconds before proceeding to the next step. During this time, various self-diagnostic routines within the vehicle complete, setting the stage for accurate fault detection. This step is fundamental in ensuring the systems are primed for testing, leading to reliable diagnostic results. Once the ignition has been activated and the wait time has elapsed, the next step is to check for DTCs again using the HDS. This essential procedure involves scanning the vehicle's systems to ascertain whether the DTC B1036 is still present. If the DTC is still indicated, it confirms a persistent error that necessitates further investigation. Should the DTC not appear, this may imply that the issue was intermittent, potentially related to faulty connections or a temporary malfunction. In such cases, it's recommended to inspect the driver's under-dash fuse relay box connector C for loose or poor connections. This step is critical as it guides the technician in determining the next course of action based on whether the issue persists or has resolved. If DTC B1036 remains active, the next troubleshooting step is to measure the voltage between the gauge control module 32P connector, terminal number 32, and the body ground. This measurement is essential for determining whether the gauge control module is receiving the necessary battery voltage from the MICU. A multimeter should be used for accurate voltage readings. If voltage is present, it indicates a possible fault in the MICU itself, necessitating replacement of the driver's under-dash fuse relay box for both USA and Canada models. Conversely, if there isn't any battery voltage detected, it points to a potential open or high-resistance issue in the wiring connecting the driver's under-dash fuse relay box to the gauge control module. Addressing these connections is critical to restoring proper voltage flow and resolving the DTC B1036. After performing the necessary repairs for the DTC B1036, it is crucial to conduct a final verification process. Begin by clearing any DTCs with the Honda Diagnostic System HDS once the repairs are completed. This step ensures that any previous fault codes are erased, allowing you to start afresh. Following this, recheck all systems that were previously affected to confirm that they are now functioning properly without any recurrent faults. It's essential to validate that all electrical components linked to the MICU, such as lighting and dashboard indicators, react correctly once the ignition is engaged. A thorough check ensures that not only was the immediate issue resolved, but also that the overall integrity of the electrical system is intact, confirming the effectiveness of the repairs undertaken. Although specific preventive maintenance guidelines for DTC B1036 may not be explicitly stated, several best practices can help minimize the risk of encountering similar issues in the future. Regular inspection of fuses, especially the number 5 7.5 amp fuse related to the driver's MICU, is critical. Ensure that all connections under the dashboard are checked periodically for loose or corroded connections, which can lead to electrical failures. Furthermore, maintaining the health of the vehicle's battery and charging system is vital. as poor battery conditions can lead to system malfunctions. Recommendations include routine battery tests and cleaning of terminals to avoid corrosion. Adopting a proactive approach to these components can significantly reduce the likelihood of encountering DTCs like B1036 in the future, promoting better vehicle reliability. In conclusion, the DTC B1036 error highlights an important aspect of electrical system integrity within the Honda Accord from 2008 to 2012. Identifying the sources of this error involves a structured diagnostic approach that begins with clearing DTCs and systematically checking components such as fuses and connections. Each troubleshooting step is imperative to accurately locate the issue, whether it relates to faulty MICU functionality or poor wiring. By following these guidelines and ensuring the final repairs are verified, technicians can restore vehicle performance and reliability. Additionally, incorporating preventive measures can further ensure longer-term functionality, reducing future DTC occurrences. Overall, a thorough understanding and methodical troubleshooting remain key to efficiently resolving DTC errors like B1036. Please like and subscribe to the channel. See you next time.